Hi, what we're going to talk about now are your combustion reactions. Okay, for the combustion reactions, what I wrote in my flip book doesn't take up very much space at all. The combustion reactions that we're going to deal with are pretty straightforward. For a combustion reaction, okay, and at any time you can pause or rewind this video, a combustion reaction is always going to be a hydrocarbon, okay? And what we mean by hydrocarbon is it's got hydrogen, it's got carbon, and then sometimes even some oxygens, okay? So if you see something with C's and H's, or C, H's, and O's, we're going to treat that as a hydrocarbon for this class, okay? So as a hydrocarbon reacts with oxygen to always yield carbon dioxide and water, okay? These reactions, you'll come to start loving them because to predict the products, it always yields carbon dioxide and water. So the general form for us will look like this. I want you to look out for compounds that have C's and H's in them. That's how you're going to know it's a hydrocarbon. And it always has to react with oxygen. You have to have oxygen as the other reactant. And they will always make carbon dioxide and water. There's no ionizing, there's no crisscross and reducing, that's all you do, okay? Now I'm going to tell you that when it comes to balancing these, always balance this last. Always balance your O2 last, okay? And let's take a look at some examples for why I'm telling you to do that. Okay, so here we go. Examples. The first example that I'm going to show you is CH4 plus O2. Okay? As soon as I see this, I'm like, oh, that's a hydrocarbon. It's reacting with oxygen. It always yields carbon dioxide and water. Okay? So then what I'm going to do is I'm going to come over here to balance. Remember I said do this last. So here we go. 1 carbon, 1 carbon. 4 hydrogen. Put a 2 there so I can make 4 hydrogen. And now let's go deal with the O's. When you come to this side, notice that the oxygens are split between the carbon dioxide and the water. So here you've got 2 of them, and over here you have made 2 of them. So on this side you have a total of 4 oxygens right here, 2 plus 2. So what I need is I need this to be 4. So what coefficient will give me 4 oxygens? That's right, a 2. 2 times 2 would give me the 4. Come over here and you put a 1. Come over here, put a 1. And you're balanced. Okay? Here's another example. This right here, C6, H12O6. That's glucose. And we react that with oxygen. As soon as you see this, this is for us, this is going to be a hydrocarbon. Okay, it's got hydrogens and carbons in it, and it's reacting with oxygen. As soon as I know it's a combustion reaction, these always make carbon dioxide and water. Okay? Now remember I told you to always balance this oxygen last. So let's go take a look and see if this works. 6 carbons, I'll make that 6. 12 hydrogens, I'll make this a 6 because 6 times 2 is 12. Okay, now I've got 6 oxygens here, so remember that, okay? All right, so let's come over here and see how many we made. 6 times 2 is 12. 6 times 1 is 6. So coming out over here, okay, I made 18. Well, this 6 cancels out that 6. So I really just need to be focused on making 12. So I need 12 oxygens. So what coefficient goes in there? It's a 6, and make that a 1. Okay, I hope that that helps, and what I'd like to point out is, just very quickly, some of the similarities and differences, okay? All right, so let's say, for instance, that you had, let's just come up with something. I probably should have thought of something first. Let's see. So let's say, for instance, that you have some hydrochloric acid reacting with some potassium, okay? It doesn't matter the order. There's your element, there's your compound, okay? As long as it's an element and a compound, then boom, that's going to be a single, okay? I'd like to show you oxygen plus a hydrocarbon. Okay, this is also an element reacting with a compound, okay? It doesn't matter the order that I write them in. This is a compound plus an element. This is a compound plus an element. So they look similar, okay? But what you need to do is you need to watch out for, this is a hydrocarbon. And as soon as you see that hydrocarbon reacting with the oxygen, it always will yield carbon dioxide and water, okay? This one up here, you have to ionize. You have to check your activity series, okay, to see if it's strong enough, if the element is strong enough to kick out the relationship, and then you can predict the products. So I hope that that helps.